Special purpose diodes and their applications. The sudden increase in current in a Zener diode is due to rupture of many covalent bonds present. Therefore, it should be connected in reverse bias. Semiconductor diode can be used as a rectifier. The function of a rectifier is that it converts an AC into DC by allowing the current to pass through in one direction. Rectifiers first convert powers into AC and use a transformer to change the voltage and finally rectifies power back to DC. Zener diode can be used as a regulator shunt to regulate the voltage across small circuits. They are always operated in a reverse biased condition. Forward biasing of PN junction offers low resistance. In case of an ideal PN junction, the registered resistance offered to 0. So forward biasing does not offer any resistance, that is R is equal to 0. The reverse current is mainly due to the drift of charges. It is due to the carriers like holes and free electrons passing through a centimeter square area that is perpendicular to the direction of flow. A PN junction diode can be used as a rectifier during the positive half cycle. The diode is forward biased and allows current through it. In PN junction with no external voltage, the electric field between the acceptor and donor ions is called as a barrier. Potential barrier created throughout the PN junction is due to diffusion of electrons and holes, that is fixed donor and acceptor ions, and this potential barrier normally does not allow charging flow through the junction. When reverse bias decreases, the depletion region width d decreases. As d increases and capacitance increases. In a reverse bias diode, the current is very low, typically in the nanoampere to picoampere range. This is because the reverse bias causes the to widen, making it difficult for current to flow across the diode. The diode acts as an insulator in the reverse bias condition. When the voltage increases up to around, measurable current starts to flow through the diode in the forward direction. As the voltage moves a little above, the current through the diode rises rapidly. A reverse bias applied to a PN diode raises the potential barrier because p-type material connected to the negative terminal and pulls the holes away from the junction. Similarly, n-type material connected to the positive terminal and pulls the electrons. Diode is a combination of p-type and n-type semiconductors. This combination creates a potential barrier at the junction. Therefore, the external power source must overcome the potential barrier to conduct. In the forward bias, the diode conducts, and in the reverse bias, it will not conduct. In forward biasing, p-type is connected with the positive terminal and n-type is connected with negative terminal of the battery. PN junctions are called diodes because they allow the flow of current in one direction and not in another. They are two terminals or distinct electrodes which are anode and cathode. Anode is a positive terminal In a forward bias PN junction diode, that P-type is linked to positive terminal and N-type is connected to the negative terminal. On this type of junction, the cathode terminal is negative, the anode is a positive charged electrode or wire that charges the PN junction with holes. We call the lead affixed to semiconductor the cathode. Therefore, the cathode is the negative side of a diode. The conventional flow of current is from P side to N side. As in the forward bias PN junction, electrons move from N side to P side, hence causing the conventional current flow from P to N. Conventional current flow is always opposite to the direction of electron flow. We can identify the positive and negative leads of a diode by using color coding and color band. A PN junction diode is often referred as one-way wall because it allows current to flow in only one direction. When a diode is forward biased, it conducts current, but when it is in reversed bias, it effectively blocks the flow of current. Germanium has a potential barrier of 0.3 eV and silicon has 0.7 eV. Reverse saturation IS or maximum I0 current during reverse bias of a PN junction diode depends on temperature, doping level, physical size of the junction. There is a series resistor connected to the circuit in order to limit the current into the diode. It is connected to the positive terminal of the DC. It works in such a way the reverse bias can also work in breakdown condition. Zener diodes are used as a voltage regulators, but they aren't called voltage regulators. They are called breakdown diodes since they operate in breakdown region. Zener diode has an incremental resistance, dynamic resistance, and the value of resistance is the inverse of the slope of current and voltage characteristics of Zener diode. Zener diode is a specifically designed diode to operate in the breakdown region without getting damaged. Because of these characteristics, it can be used as a constant voltage device. A Zener diode is heavily doped so that the breakdown voltage occurs at a lower voltage. If it is lightly or moderately doped, it would break down at a comparatively high voltage and thus would not be able to serve its purpose. As the frequency of the incident radiation increases, the kinetic energies of the emitted electrons are higher and therefore require more repulsive force to be applied to stop them. The value of saturation current increases as the intensity of the incident radiation increases. The value of cutoff potential decreases as the frequency decreases. A Zener diode, once in the breakdown region, keeps the voltage in the circuit to which it is connected as constant, thus is widely used as a voltage regulator. The symbols of Zener diode and normal PN junction diode. In normal PN junction diodes, the breakdown takes place by avalanche. breakdown, which is different from the Zener breakdown. Zener diode is specially made to operate in that region. Zener diode is fabricated by heavily doping both P and N side of the junction, which results in an extremely thin depletion layer or region. A light emitting diode LED is heavily doped. It works under the forward bias conditions. When the electrons recombine the holes, the energy released in the form of photons causes the production of light. GaAs has an energy band gap of 1.4 eV. It can be used to produce infrared LED. Various combinations can be used to produce LED of different colors. The reversed breakdown voltages of LEDs are very low, typically around 5 volt. So if excess voltage is provided, they will get fused. Semiconductors with band gap close to 1.8 eV are ideal materials for LED. They are made with semiconductors like GAS, GASP, etc. The LED works when the PN junction is forward biased, that is, P side of is connected to the positive terminal and N side to the negative terminal. In the current voltage characteristics of an LED, as the frequency increases, the voltage required to achieve the same current increases. Hence, A would be the highest wavelength. As the forward current is increased for an LED, the intensity of the light increases up to a certain maximum value. After that, intensity starts decreasing. When the recombination of electrons with holes takes place, the energy is released in the form of photon. This photon is responsible for the emission of light. The warm-up time required should be lower so that the lighting action can take place faster. This is one of the advantages LED have over the incandescent lamp. Electroluminescence is an electrical and optical phenomenon where material emits light when electricity flows through it. Little or no warm-up time is needed for light-emitting diodes. Aluminum alloys are used to obtain yellow, orange, and red color lights. The sudden increase in current in a Zener diode is due to the rupture of the many covalent bonds present. Therefore, the Zener diode should be connected in the reversed bias. Pure semiconductors are called intrinsic semiconductors. The number of electrons in the conduction band will be equal to the number of holes in the valence bond. Intrinsic semiconductors are also undoped and I-type semiconductors. In substances such as gallium, boron, and aluminum are all trivalent atoms. These are called acceptor impurities and they produce p-type semiconductor. Therefore, germanium is doped with gallium in a p-type semiconductor. Holes are the majority charge carriers in p-type semiconductor. These holes are actually electron vacancies that contains positive charge. The holes are responsible for the conduction in p-type semiconductor. A light emitting diode LED converts electric energy into light energy. A LED is a heavily doped PN junction which, under forward bias, emits spontaneous radiations. The semiconductor used for the fabrication of visible LEDs must at least have a band gap of 1.8 electron volt. Filtering is frequently done by shunting the load with capacitor. It depends on the fact that a capacitor stores energy when conducting and delivers energy during non-conduction. Throughout this process, ripples are eliminated. The T is the total non-conducting time of capacitor. The charge per unit time will give the current flow. Therefore, the charge Q lost by the capacitor during the discharge time for shunt capacitor filter is IDC into T. The rectifier may be full wave or half wave. The capacitor filter is usually electrolytic capacitor, even though they are large in size. Ripple waveforms will be triangular in nature. The RMS value of this wave is independent of slopes or length of the straight lines. It depends only on the peak values, that is IDC by 2 root 3. The presence of inductor usually dampens the AC signal due to the self-induction induces opposing EMF or changes in the current. The inductor does not allow the AC components to pass through the filter. The main purpose of using an inductor filter is to avoid the ripples. By using this property, the inductor offers an infinite resistance to AC components and gives a smooth output. Source of supply will be a battery, dry cell, or full wave rectifier. Ripples are AC components and filters are used for eliminating AC components from the signal. Load regulation is the process of fractional change of output voltage when load current is increased from 0 to maximum value. Zener diodes in DC power supplies are used for providing a reference voltage used for comparison. Stability of Zener diodes used in an important factor in determining the stability of output voltage in DC power supply. Standard values of Zener diode voltage are 5.1, 5.6, 6.2, and 9.1 volt. If the Zener diode of temperature coefficient of about minus 2 millivolt is connected with a forward diode which has a temperature coefficient of about plus 2 millivolt in series, the combination can be used to obtain a very low, close to zero temperature coefficient. UPS, uninterruptible power supply, is used where loads or temporary power failure can cause a great deal of inconvenience. When the supply is gone, the diesel engine is started, which runs the alternator, and alternator supplies power to the mains. Non-rotating type UPS are not used anymore. Static UPS require both inverter and rectifier, where rectifier to converter the DC from the battery to AC, inverter to charge the battery from mains. Usually, lead acid batteries are cheaper and have certain advantages over other types. NC battery would, however, be the best, but are 3 to 4 times more expensive than lead acid battery. UPS uninterrupted power supply is required for computer for backup. A very smooth output can be obtained by a filter consisting of one inductor and two capacitors connected across each other. They are arranged in the form of letter pi, so these are also called as a pi filters. The capacitor offers a very low reactance to the ripple frequency. The CLC filters are used when high voltage and low ripple frequency is needed. Then L section filters. The capacitors in a CLC filter offers very low reactance to the ripple frequency, so maximum of the filtering is done by the first capacitor across the L section part. Inductor offers zero resistance to DC component and high reactance to AC component. So inductor blocks the AC component which cannot be bypassed by the capacitors. The output contains along with the DC components the AC harmonics which does not useful work and reduces the efficiency. A rectifier is used to convert AC to DC, lower the AC, that is non-DC components in the output, lower are the ohmic losses. Inductor has a very important property that current through it cannot change rapidly. We can make use of this property by connecting it in series. Inductor filter offers high impedance to AC and low resistance to DC, such as the AC ripples do not pass through the load. AC ripples are not allowed to pass by short circuiting the AC ripples as the C is always connected in parallel with the load. The capacitor charges when the diode is in on position and discharges during the off state of the diode. The instant at which the conduction starts is called as a cut-in point. The instant at which conduction stops is called cutout point. The rectifier current is a short duration pulses which causes the diode to act as a switch. The diode permits charge to flow in the capacitor when the transformer voltage exceeds the capacitor voltage. It disconnects the power source when the transformer voltage falls below that of a capacitor. Since the rectifier conducts current only in the forward direction, any energy discharged by the capacitor will flow into the load. This results in a DC voltage upon which is superimposed a waveform referred to as a sawtooth wave. When p-type semiconductor is mixed with n-type semiconductor, p-n junction is formed. This is very small region which is in order of micrometer. This region is known as a depletion region. So the thickness of junction depletion region is in order of 10 to 6 meter. In the depletion region of an unbiased PN junction diode, there are only fixed ions. where no mobile charge carriers are present. It acts like a barrier that opposes the flow of electrons from N side and holes from P side. Zener breakdown occurs where breakdown voltage is below 6 volt and avalanche breakdown occurs for other voltages. When biased correctly, the Zener diode has a constant voltage across it. In depletion region, an electric field exists that quickly sweeps out electron hole pair that may be thermally generated and reduces the equilibrium concentration of the charge carriers to exceedingly low levels. Under these circumstances, this region called depletion layer behaves as an insulator. The two capacitors involvement in addition with one inductor. It produces filtering action. This leads to decrement in ripple factor. A low ripple factor means ratio of the current due to AC ripples and direct current is flow. Rectifier electrical device converts AC to DC by using one or more PN junction diodes, but the output of the rectifiers is pulsating, means contains both AC and DC components. Hence, to remove all the ripples, that is AC components from the rectified output, we use filters. The ripple factors of LC filter remains constant with the load current. Commercial power supplies have voltage regulation within 1%. The DC voltage output is dependent on an internal voltage reduction transformer and should be matched as closely as possible to the current required by the load. Typically, the output voltage will decrease as the current output current to the load increases. If two similar 15-volt Janers are connected in series, then 30 volt is the regulated output voltage. A low impedance allows the source to deliver current without significant voltage drop, ensuring the voltage remains stable even when connected to different loads. This is important for many electrical and electronic systems where a stable voltage is required for proper operation. A Zener diode utilizes reverse characteristics for voltage regulation. Zener diode begins regulation operation only when input voltage is equal or more than breakdown Zener voltage. Otherwise, the diode remains off state due to the parallel operation with load. Zener diodes are referred to as shunt voltage regulators. For Zener voltage less than 5 voltage, then temperature coefficient is negative. Zener voltage is greater than or equal to 5 voltage, then temperature coefficient can be made 0. If Zener voltage is greater than values, then temperature coefficient is positive. Nowadays, ICs have been widely adopted by the industries over conventional Zener diodes as their better replacement for a voltage regulators. Thank you very much. Special purpose diodes.